Hi, everybody. Our next speaker is Florenz Hollebrandse. He's a senior leader at ING of data and analytics. And today he's going to share his experience about what makes some projects not pass from the pilot phase to deployment and how we can avoid this. So let's give a round of applause for our speaker. Thank you. And the floor is yours.
Thank you, Maria. Thank you, everyone, for coming to this talk, and thank you for having the opportunity to speak here at PyData. I was just saying there, I'm trying to preach to the ING colleagues here as well, so if you feel offended, then it's intended for the ING colleagues. But I feel like working for a bank, there's some stuff that we do really well, and kind of doing AI project to scale is something that banks generally do pretty well because we've got the resources to our availability, but it also matters. I work in financial crime and fraud prevention, and getting that right, that matters, not just for compliance, but also as a duty towards our customers. So I'd like to talk a little bit about this kind of catchy title about improving the model development lifecycle, improving our projects, increasing the chances of success, and hopefully making a little bit faster as well. I'm going to split this into two parts. The first part is a little bit more abstract, so you might like that or you might not. And if you don't like that part, the second part is hopefully a little bit more practical, give you some tooling that you could use in your project. So the first part, breaking down some barriers in your projects. Now, depending on the organization where you come from, kind of breaking down barriers might sound like something like, why would you worry about that? Are there any barriers? But often when we look at AI projects, we have this kind of two-aspect dynamic going on. Two aspects, one product. I was starting off with one project, but actually I think it's more useful to talk about product because we're building one solution and it has a number of aspects. On the left-hand side, you see kind of dealing with structured, unstructured data, doing some exploratory work on that, kind of do some data mining, discovering trends, and then ultimately try to come up with an algorithm that we can optimize, that we can evaluate and talk about metrics and squeezing every final inch out of the data that there is. And that's sometimes a little bit of a messy kind of process. On the right-hand side, you will probably recognize it. We have a lot of the kind of more engineering, more deployment-focused aspects. So that talks about, what is your architecture? How should you design your solution? Talking about reproducible data pipelines, even software testing, kind of how do we know what we're building is fit for purpose, stable, and then also coming to the kind of cloud deployment aspect and everything that comes with it, from security, auto-scaling, vulnerability management, cost management. Those are quite distinct aspects to one and the same project. Let me talk about a different concept that is helpful, I think, here to understand. And can I have some hands up who's heard about Conway's Law before? Quite a few have heard about it. If you haven't, it's pretty simple. Mr. Conway, he was like a researcher, software engineer. This is 1969, so probably kind of well before most of you were born. And Conway came to the observation. It was an observation. It wasn't a statement that he said this should be the case. He made the observation that if you look at organizations, then he said they design a system and it will inevitably produce a design whose structure is a copy of the organization communication structure. What does that mean? He kind of summarized it already like systems image their design groups. He said, if you look at the teams in an organization, the IT teams, the technology teams, if you're looking at the IT landscape, you'll see that mirrored. Now, why is that important to recognize here? If I talked about those two aspects, like often organizations start with, you have to have some center of excellence for machine learning AI, or an AI research team. What will that team build? Well, kind of researchy kind of things, right? If you've got traditional application engineering teams, what will they build? Proper systems that run. Bringing those two together, if they are separate parts of your organization is not necessarily trivial. You can see that in many ways. You can see that in AI, you can see that in any sort of large enterprise landscape. You'll see if you split your team in two, what's going to happen? Part one going to look after their stack. Part two going to look after their part. It will evolve in separate directions. If you have a global organization, if you make an US division, an EMEA division, those solutions, you could say they should be consistent, should be the same, but they're going to evolve in different ways. It's important to recognize that that is really difficult to counter. So ING kind of early in September put this question on LinkedIn: what's the biggest hurdle of scaling your AI solutions? And guess what? Somewhat similar answer comes out there. Quite a lot of people say, well, you know, the way we organize our company organization is a little bit messy. We don't really know what the responsibilities are. We don't know really who's doing what, and it could actually break down projects at critical stages, early stages, late stages. Other people said, you know, okay, that's one thing about infrastructure issues, and what we probably mean with those kind of things is, for example, data availability. You know, being able to scale stuff like that. That's the kind of soft, kind of non-technical bit, I think, that's really important to recognize. But if we're doing a little bit more practical, looking at like what are the phases of an actual project. You know, if you're a software engineer, the term of kind of waterfall design is something that sounds very familiar, and you can recognize that also in machine learning projects, where you have start with a phase of experimentation, finding an algorithm in your data, coming up with a model, having that model then independently reviewed with some other teams to check it's compliant with all policies and it's fit for purpose, and then finally the solution, productization. Building it out, integrating it with the rest of the landscape. Many people probably recognize those steps in one way or another. It's often something that more or less kind of sequentially happens. But you probably think about, well, actually, is there not something like the Model Development Lifecycle? Is this not a thing that actually should be circular? And if you Google this, if you read kind of textbooks or blog posts, people come up with different forms of this one and the same diagram. Again, starts with experimentation, followed by kind of training, then your final algorithm against your data, the model review, the integration part, the engineering part comes that. But then this is where the critical piece comes in, is actually then following that up with some model monitoring to look at, you know, the data that I'm seeing in real time going forward. Is that representative of how I've trained it? Or do I need to start the cycle again and go back to my experimentation to look at model improvements? You know, the theory. Does anyone run like a circle? Well, sometimes the circle takes a little bit long, and then we kind of stop after one cycle because we've got tired and we have got a new project to deliver. And one of the things that I'd like to hear kind of introduce is this concept about, you know, why is that cycle sometimes a little bit long? And if we run a kind of sequential, then you can say, well, each of those phases could take a set amount of time. And does it have to be as long as it sometimes takes? Because the model training step, the step two, this is where our data scientist friends would say, this is where the job is done, right? I've got the model, it's finished, right? Just bloody get it in production. Senior managers say, when can you get it in production, right? Shouldn't take you long. You heard that phrase? Shouldn't take you long, right? The other bits, you know, needs to be done, but please let it not take too long because it's the boring part. And, you know, quite rightly, it is the boring part, right? Because looking at your data is the interesting bit, what you can take out of this. But I'm trying to here put this upside down, and this is why I call flip the plan, kind of going back to front. When you run a project, when you're running a machine learning project, that you start with model integration from day one. But at the same time, you do your data exploration and your model training just as a parallel activity. Yeah. And then finally, kind of you can model your review, kind of, and your feedback loop for your model monitoring kind of happens in its own time scales. That sounds like we could cut it down a little bit, right? You know, if I just subjectively here draw on the screen, then I'm saying, you know, cut it down by 50%. Anyone thinks 50% cutting down is realistic? I see some people that probably like have done this a bit before, so they say, look, I've got this sorted in my team. This is actually what we're doing, right? Because it sounds like, you know, a nice theory. And what would it need for a product to run like that? Is it actually possible to start out the integration part on day one? Well, first of all, Conway's law. If your organization is a bit messy, you have different people responsible for different parts, if you've got a really professional data warehouse and a data lake and data pipelines and the separate teams you need to ask for the data to be prepared for you, it's going to be difficult, right, a collaboration. If you work with data scientists that sit maybe in a kind of more of a research wing of your organization, you know, you need to convince them that you're going to look and work with them from day one to see what it takes to integrate this in production. So collaboration, the theory, is essential there, but you have to have the right project team together to make that possible. Let me look at with you at the more practical side of this. Because you could see it as a project management theory, you could see it also as something that you could translate into your architecture and your engineering approaches in your organization. I'm going to kind of go from a slightly higher level, drilling it down. I'm going to show you some code that explain to you what I mean. So remember, back to front is start with the integration, start with the inference. Forget about the model training for a minute. Think about what would your inference look like. I'm going to just introduce two example projects here. One is from my previous employer, JP Morgan, and the second example is from ING, a more recent project. And I'm talking you a little bit through this architectural diagram, a very high-level simplified view of what's happening. So this is what we call an alerting system for credit risk officers. So those credit risk officers, they all have like companies in their portfolio that they need to review from time to time just to see, you know, is the credit still kind of the credit lines are still adequate, or there need to be adjustments, or do there need to be conversations with the client, etc. And one of the things is that those credit risk officers do, they will try to keep up with the news. And obviously, if you say, well, actually, if we're processing news at a global scale in a more automated way, we could do some sentiment analysis and we could do some proactive alerts for those credit officers. That's exactly what was built here. What does that mean in terms of back to front? So you have this credit risk application as a UI. It's a traditional application with a back-end database. It's a front-end desktop application. So that is like teams, they're responsible for that. They probably don't know that much in detail about what analytics and what running an AI project looks like. And it doesn't need to be. But day one, the first sprint of that project, is actually look with them, well, actually, what is our integration point? And here, this is a real-time push system, so there's a Kafka messaging-based solution. What's important there? Well, you have a Kafka topic that everybody can connect to that, the producer and the consumer, but do we agree on the data format? Do we agree on the schema? So here's like, you know, you might say, okay, it should be Avro. Here the client said, actually, the consumer said, well, for us, JSON schema makes a lot more sense. It's all possible. You iterate over that, you design that, and you deploy that straight away. The Kafka topic is there. The schema is in the schema register. They can consume that from the schema register. Step one, done. The integration point defined. Then you can work your way backwards. So the whole orchestration of this model is real-time taking signals from news events, so when an article is being published. There's some sort of like workflow management that needs to be done. What we did, well, I said, actually, you know, having a Kafka topic, nothing on there is a bit theoretical. Why don't we just do a dummy orchestrator that's kind of randomly pushes alerts with saying, yes, for this company, for this customer, there should be alert, and for another company, maybe not, right? So that means no message. That's pretty much sprint 2, right? You have messages going there. First of all, straight away, feedback from the client, from the consuming application saying, oh, you're sending customer IDs that we don't have in our database. Yeah, exactly, because we just randomly generated. What is the edge case here? Could that happen in production? Are we solving that question straight away, right? Really kind of advantageous to do that early phases. And then finally is, say, plugging your database event to make the model orchestration actually run when news arrive. All of this time, the model might be replaced from always saying, yes, there's an alert for every customer, to making it random with different probabilities to tune the volumes that we get through. But finally, of course, we then backfill that with an actual model that the data scientist did develop in the meantime. And the data scientist kind of knew already from sprint 1 and 2 as well what that interface should look like, how that model should be connected with this model orchestrator. Second example is at ING, as I said, within the KYC, kind of know your customer kind of services. Does anyone know how long it takes to open a current account with ING here in the Netherlands? 6 weeks. 6 weeks. Does someone want to beat this? Who says 48 hours? So 48, so who says less than 24 hours? Okay. Who says less than 10 minutes? Okay, there's some customers there, so. Because in the Netherlands, if you have your mobile phone app and you hold it to your passport, then all of the KYC processes are happening kind of in real time behind the scene, right? It's beautiful. In the Netherlands, we're quite fancy with kind of hooking up our population registry with kind of banks and stuff like that, and it's all secure, I can assure you that. If you're in a different country, that might not be possible. But the know your customer process should be kind of as seamless as possible for everybody, right? Behind the scene, there's currently kind of quite a lot of like manual rules are implemented to say, well, look, if you give a Netherlands address, but you give kind of a telephone number that's actually registered in North Korea, probably need to check something with you, right? Because before we give you a current account, because the regulators might not want us to facilitate whatever activity you might be doing in that country. So quite similar. If we starting from the right-hand side, we have this traditional application, kind of a workflow application for this whole KYC process, which does the kind of rules, and if the rules kind of fail, that then humans are in the loop to review the cases. Again here, so what do we kind of start with? Agreeing with them, what is your contract? So this is real-time request-based inference. So not like the other scenario where it's push-based inference, HTTP APIs, cloud-native solutions. What should it look like? What does the payload look like? What should the request look like? But probably more importantly, kind of what are the failure scenarios look like? What if KYC application sends a request for a customer that doesn't exist in the central customer database? It's like if there is a synchronization mismatch between data in the two systems. Those are important questions to deal with. What about availability, right? If customer experience is compromised on a Saturday morning, right? It wouldn't be great because people probably on a Saturday morning sort all out their home administration, right? So what are the non-functional requirements on that? Sort it out day one. And then finally, kind of once you have got that orchestration going, once you have got the real-time inference end-to-end integrated, again, with some sort of random placeholder model, only then you can think about, okay, all of the fancy work that the data scientists have been doing, what data pipelines do I need to have in place there and join it all up with my warehouse. It's probably fair to say that kind of the way this project was run, the exploratory work started quite a few months before this started. But still the theory that you could have done this all in parallel, all at the same time, and agreeing between the different stakeholders what the solution should look like, that is still a valid model if you ask me. So let's drill down a little bit further in what's behind the scenes for an engineer to say, actually, you're saying start with inference on day one. Where do we start? I don't have a model. Right? Okay, well, I said, some of the scaffolding, some of the kind of data contract aspects. So let me look in this diagram with you about have this more generic, this business application on the right-hand side and connect it with a container that hosts my model. So it's a real-time inference request-based cloud-native solutions. We say, okay, what do we need to have there? An HTTP web server, an API server. Everything that comes with an API is kind of response status code, payload, request, all of that sort of things. Then working from the bottom, well, to enable this, our business logic is I need to be able to load a model that I've trained ad hoc, manually, or a model that I'm retraining on the fly every so often. Invoking the model, it is a second building block there. And those two bottom bits, this is where you should spend most of your time kind of figuring out what should go in there, right? The magic bit here is kind of abstracting what's above the middle block from what's below it. So the model logic at the bottom and the rest of my integration, my engineering concerns at the top. And I'm introducing this concept of a bridge layer. Now, if you Google that, that doesn't really make sense outside this talk, right? I'm just inventing an abstraction. There's something above and something below. Below, purely the model logic, above, purely integration. And if I can decouple that I don't have to manually wire up those two things, if I really can get the scaffolding going in a very easy way at day one, then I can be able to make this head start where I say start with inference on day one. An example of one of those bridge layers that does this is this project that we did at JP Morgan last year or thereabouts that we said, okay, this should be simple, right? We call it inference server. It's like optimized for Amazon, but actually the design is very kind of cloud agnostic. You could run this at home in your own Docker environment. At ING, we're actually kind of running this in GCP and Cloud Run as just a standard container. There's nothing special about it. Please do check it out. I think it's showing a few kind of nice patterns. It's nothing unusual. If you're an MLflow user, you might recognize some of the patterns there. But the intention here is to make it really simple and understand what the correct workflow should look like from abstracting away the model from deployment concerns to exactly enable that. And the way the framework works is by defining just two main functions, or four functions, depending how you look at it, in a pluggable way. So you don't need to do the scaffolding, you don't need to wire up, you just define those functions. And you will recognize like a model function, that is that building block on the left-hand side. Predict function is the building block on the bottom right-hand side. Those two define your model. So for example, if this was a scikit-learn model, what would model function look like? Loading a pickle file, probably. If it's a PyTorch model, they have got their own format, right? If this is a whatever model, whatever flavor you have, anything you can put in there, and it's specific for your framework. Your predict function, what would that look like? Again, in scikit-learn, .predict proba, whatever you fancy, right? Anything. Anything you can kind of write in Python, you can put in there. It's not the point. The point is making it simple, easy to recognize what those functions are for. This is then where the magic comes in. I call it magic, you will say, duh. Obviously you would do it like that, right? Fair enough, if that's an obvious conclusion. Inference server as a framework, out of the box by default says, you don't need to implement any of those functions. If you do this back to front, if you deploy this without implementing anything, without writing any code, this is the logic you get, the default plugin. What does the default plugin look like? It defines a model, give it input, get an output. Now, what would be a sensible default model? You can't really think about it, but here would have said a sensible default model is just echoing the input back as output. Complies with the contract, input, output. So here, if you know your Python kind of Lambda, input data, return data itself. Super, out of the box. This is not something you need to write. Same with predict function. Given that model that you've just shown, how would you make a prediction with it? Well, call that model, call that Lambda function with the input data. And then there's only the last bit. So this is what the engineer could do on day one. Write this Docker file. And that maps like this back to our diagram. Clearly separating out, you've got my web server layer. As long as it's a Python Whiskey standard one, don't care what it is, you can choose. You could fine-tune it, optimize it the way you like it. Inference server, that's our bridge layer. And without anything, this Docker file, this runs, right? You've got the whole diagram on the right hand up and running. You can deploy it to your cloud environment if that's Amazon SageMaker or your local Kubernetes setup. You can start your integration from day one. And you've got something that your consuming application can invoke and get an answer back. Once you've done that, then you're going to backfill those 4 functions, the 2 functions, depending how you look at it. So I've got some take-home messages. Hopefully they kind of summarize a little bit what we've discussed here. And the first one is really kind of this collaboration, right? Don't sit in silos just because you define some data team versus some machine learning engineering team versus, a regional data science team that has no connection with you. Kind of find the connections, find the stakeholders that you need to collaborate with. And if your organization is messy, this is going to be hard. Like Conway's Law is real. Just be aware of that. Fight at the right level. Don't try to change your entire organization. Second message is from my friend Stan. Productization starts on day one. Please remember, productization starts on day one. When you have an initiative, when you have a use case, how will we deploy this to production? Can I get access to my data? What does my data flows look like? Is it real-time inference? Is it push-based? All of that. Not on day 2. Not after we've got some proof that the algorithm's probably going to work. No, day 1. Finally, build back to front. Start with inference. Use some tooling that help you to actually implement that in code. If you use this inference server framework, gets you up and running quite quick, but your own platform might have other techniques that you can use that, from the stubbing a model to writing your data contracts at first. Thank you very much.
Thank you. That was a very interesting talk. We have some time for a few questions from the audience. Yes, we'll start with you.
Thank you for the talk, first of all. Regarding point number 1, I feel like this is the toughest part. I'm also working at the bank right now. There's also security that is very important. Data is not really in a data lake, or it's getting there. Yeah, do you have any other, let's say, tips you would give, or considerations to improve on that? Maybe, I think team setup is a big part, for example.
Team setup is a big part, right? Try to get the smallest possible team that's responsible end to end. Like in engineering, we talked about full stack engineering, kind of as a concept is a bit out of fashion because, full stack, it depends where you cut it, right? But with data projects, analytical projects, you really need to have somewhat guarantees that productization is taken into account from day 1, ideally by a small team that can take ownership for the full cycle. I think the trap that we often see, particularly the larger your organization, is there will be someone that says, I'm going to make this one data platform that's going to solve all of those problems, right? Everybody wants to invent a data platform, right? You can just buy it with your effing credit card at Google, Amazon, Microsoft, right? please don't fall into the trap that like, yeah, next year we've got this platform solves all your problem, you've got straight away access, you could do fast experimentation. No, bring it down to simple building blocks, simple abstractions that you can start from day one. You see with this Docker file, I don't necessarily need much more just to do real-time inference, right? In its simplest way.
Thank you.
Yeah, hi. Thanks very much for the talk. It's there are a lot of things that I recognize. I'm sort of, I guess, heading up a production team, work a lot of with data scientists. Two issues that we're facing, I'm hoping to sort of learn more about the sort of bridge layer and maybe understand more of the function that it, or the problems that it could solve. Like two problems that we're seeing, that I'm seeing is, first of all, the product management or the sort of business people, they want to apply custom rules around the models all the time. And they don't know yet what they're going to be, but they know they're going to want them. And the second problem that we're facing is the sort of requirements from this business app that you had as number one, that it keeps changing. So the shifting goalposts around data scientists, they never stop training a model, they keep sort of updating it. And how do you deal with those kind of things?
Yeah, exactly. And that's why, you know, none of that is like rocket science as such. It's about following due processes. I think some of the kind of architectural kind of solutions that I'm putting in there helps you to identify the individual building blocks and helps you to focus on what's important. When you say, for example, shifting requirements or inputs and outputs, to really say, okay, this is the first thing that we can spend a little bit of time on, which is on the data contracts, the exchange. Where does the exchange between an analytical function for traditional workflow management, right? That's not trivial to solve, right? And if saying, you know, we're going to spend in the first sprint bringing all the stakeholders to have something that's like fit for purpose, practical, but also possibly future-proof, that any extensions we could foresee, we know how we're going to do that. I think that's the way it helps it. Not everybody kind of just getting frazzled about, but this model needs to be trained and we need to get all the data in the same place. And then this becomes an afterthought. Yeah.
We have time for one more question. I will take a question from the back.
Thanks for your talk. In my situation, I work as a data scientist. We don't follow this practice, but I also recognize a lot of what you said. However, sometimes I and my team, we do fail. So we don't deliver a model that's just good enough. And if we take this approach, I'm worried that someone else will do some work for nothing, basically. And I wonder what you would say to that.
Yeah. That's fair, because that's often what people say, and that's why I explicitly said here, but we need to have some sort of confirmation that my data is going to work. I still feel that we should start with productization on day one. Even if this answer to this question is not clear, if people really have doubt, that you still straight away say, okay, let's have this conversation, because the solution design for the end-to-end workflow, that takes a little bit of time. Like in one sprint, you can do a little bit of exploratory work. So cutting your losses after one sprint, even if you've spent a bit of time, is in most organizations worth it than waiting that late, because then you've missed a lot of work that needed to be done, and then you've got a lot of rework to trace back from. Yeah. So it's a bit of risk-taking, but most of the time that is worth it, yeah. Are we up for time?
Out of time, yes. Thank you so much. It was very insightful.